Hello everyone, Mr. Milson here. We're going to be taking a look at our part 3 in our packet. We're looking at systems of equations with 3 variables. This is on the middle of page 9. So we have some fill in the blanks here to get us started off. And this section is going to be a lot like looking at the intersection between two lines. But in this case, we actually have 3 variables. So lines had 2 variables, x and y. We're going to be looking at equations that have 3 variables, x, y, and z. So let's look at this first fill in the blank. A linear equation in 3 variables, x, y, and z, is an equation of the form ax plus by plus cz is equal to d, where a, b, and c are not all 0. The problem with this fill in the blank is I didn't leave anything for us to actually fill in. I probably meant to cross out the word variable. We would have written the word variables in here, but I forgot to. So you don't have to if you don't want to. So this time we're dealing with an equation that has 3 variables, x, y, and z. And the equation is in this format, where a is just a number in front of x, b is a number in front of y, and c is a number in front of d equal to another number, just like what we would see over here. A is 2, a number x, the number 1 in front of y, and the number -1 in front of z, and just equal to a number. And these all are examples of a linear equation with 3 variables. To the right, we have an example of when we had multiple things and we think about these as arguments, this is a system. This whole section, we're talking about different kinds of systems. This is a system, no S. This is a system of 3 linear equations in 3 variables. And what we're always looking for is we're looking for the solution. We're looking for the solution of such a system. In this case, if we're looking at this, is an ordered triple. So before we were looking at ordered pairs, right? When a line intersects, they intersect at a point, we call that an ordered pair. And these ordered triples now are going to have 3 numbers, x, y, and z, where before our ordered pairs obviously only had 2 numbers. So last but not least, we're saying that the graph of a linear inequation in 3 variables is a plane in 3-dimensional space. 3-dimensional space. So we're thinking about these as planes that kind of go out, extend in multiple directions, and we're looking at multiple planes and we're looking at where they intersect. And we'll take a look at what these kind of are down here. I know this is in print off all that nicely, so I'm going to take a look at what we had here. So let's take a look at these images for a second. So this first image up here, we have 3 planes. So we have kind of this red plane in the back, the blue plane kind of going through the middle, and the green plane going down as well. So all 3 of these planes kind of look like they intersect at this one black point. So this one black point we can think of is the exactly one solution. So all 3 of our planes are intersecting at exactly one point. This is actually going to be what we're looking at mostly, guys. We're not really going to be dealing with much of these other ones, but it's good to recognize what they look like. We also have the option of infinitely many solutions. The way that looks is we have the blue and the green and the red. They're all intersecting at the same line. So they almost have the same idea of slope. So it's not slope because these aren't lines, these are planes. But they have the same idea of slope where they increase or they're going up and down at the same, I guess, slope basically. But they're all intersecting at that one line. And last but not least, we have no solution. And really, we can think about these as, well, they have kind of the same slope idea over here, but it's intersecting at a line between green and red, blue and green, and red and blue, but none of those lines are ever going to intersect because they're going at the same rate. So here we have no solution because even though 2 of them are meeting up here, here, and here, they're never all 3 meeting at the same place. And I think this kind of makes sense here if we look at these last 2 pictures. We have the red plane and the green and the blue. The green and the blue are obviously never going to touch, and because of they're never going to touch, red is never going to meet all 3 of them. And then if we have just 3 kind of on top of each other that never intersect, those are obviously never going to intersect. But more often than not, we're going to be looking at exactly one solution here. All right. All right, so I'm going to make another video for example, what's our next example? We're going on to example 3. 3. So example 3 and 4, I'm going to make separate videos. So see you there.